Hello, this is Courtney Wood, and here's your tutorial with the math questions that you sent me. So hopefully this focuses a little bit here. Hang on. I want it to focus on the actual thing and not the glass. Okay, sure. So you have your question, which is your function, which is 1/3 of e to the 3x plus e to the negative 3x. Okay, and you want to find out what the derivative of this function is. So, how to do this? As a quick recap, the derivative of e to the x is always e to the x. Super easy, we already know that. Now, let's just say you had a more complicated function. Let's say your function was instead e to the 2x, and you wanted to find out what the derivative is. So with this one, you very similarly, basically you take e to whatever the exponent is, and you multiply that by the derivative of the exponent. So derivative of the exponent in this case is going to be what? Derivative of e to the 2x is just 2. So I'm going to go 2 times my e to my exponent. And I leave the exponent alone. The exponent always stays the same. So just as a quick recap. So therefore, oh, and then the reason this works, though, in case you're kind of like, hey, but why do you do the derivative of the of the 2x, for example? So the reason has to do with chain rule. So although we know that e to the x is its derivative of e to the x, we don't say instantly know what the derivative of e to the 2x is, right? That's not like a proven thing. So how we do that is we say, okay, fine. Well, you know what? Maybe we substitute instead of like 2x, we say it's u. Okay, so then we can know what e to the u's derivative is. If this is our function, then we know that the derivative of this one is e to the u, right? However, we want it in terms of x. So just as a recap on the chain rule, let's say what we really want to find is the derivative of, you know, this thing with respect to x, right? Then we can also state that the derivative of u, oh shoot, sorry, my bad. Derivative of our function, i.e. this thing, with respect to u, okay, times du dx, remember these will cancel out, to get us our original thing, derivative of function with respect to x. I could still write it like this, except that the problem is, of course, when you're driving with respect to u, it has to be in terms of u. So that's why it's just nicer to, you know, just write df, okay? So it's our function in terms of u, right? So there you go. So then in this case, literally the exact same thing. So our derivative of function with respect to u, this is now our new function. I should write the u here, okay? So our derivative of our function with respect to u obviously is just going to be e to the u, as we know, times derivative of u with respect to x, okay? So what was our u? We said that u was 2x. Good. What's the derivative of this with respect to x? Should just be 2, right? We agree? And then, of course, you got to plug in your x terms instead of your u terms, okay? So let's actually do our problem now. So that was a really long, drawn-out process to explain how to differentiate these things and, of course, the importance of chain rule. Okie dokie. So let's move on. Blah, blah, blah. Okay, so we're trying to find the derivative of our function. So what we do is, so we can use, in this case, a kind of a product rule, I suppose. So if you want to consider that this is like our f function and this is our g function here, for example, then you could use like product rule, right? So for example, it's really easy though, because we know the derivative of 1/3 is going to be 0. So it's really not a product rule at all, because you can just skip that step entirely. So forget what I said, just do it this way. So we know the derivative of this is going to be 1/3 times the derivative of the interior function. You agree with that? I hope. Okay, so then going forwards, we just have to find the derivative of the interior function. So let's do this. Derivative of e to the 3x, right? is the derivative of the exponent, okay, times e to the unchanged exponent plus this one. So we have our derivative of the exponent is going to be -3, okay, times e to the -3x. Good? Okay, so, and then going from there, it's just a question of simplifying it a little bit, right? So as you can see, I'm noting right now that I can factor out 3's out of everything. So check this out. I have 1/3. I can factor a 3 out of all of this, as well as a e3x. So 3e3x, and then I go times 1 minus, oh, scheiße. No. Sorry, I can't actually take out a e3x because I have an e to the -3x. So just ignore what I said. Yeah, just ignore what I said. Don't do that. So I have e3x, right? And then I go minus e -3x. Okay, cool. And as you can see, this will cancel out and this will cancel out because 3 divided by 3 is 1. And we are left with this, e3x minus e to the -3x. Okay, so now, yeah, I guess that's like pretty well it. I don't know if your prof would want you to like simplify this anymore. You hypothetically could. Whatever, you could do something like this. And then in order to make this true, this times this has to be equal. So you go like, and then when you'd add these together, sure, you could do that, but I think that's kind of silly and not necessary. I would probably stick with this answer. Sound good? Oh, and then just FYI, how I did this is I'm like, okay, well, what, like this, something plus 3x needs to give me -3x. So I said -6x. Okay, and that's that question. Hopefully that works out.